Hidden inside a recent SpaceX IPO filing is a line item that has nothing to do with rockets. It reveals a quiet infrastructure agreement that exposes exactly what it takes to compete in artificial intelligence today. The filing shows the AI company Anthropic is paying $1.25 billion every single month for access to computing infrastructure controlled by Elon Musk. That money buys time on COLOSSUS, a facility built to be the largest GPU cluster in the world. It houses the physical hardware required to train the absolute cutting edge of frontier models. Survival at this level, trying to build the most capable machines on the planet, now requires the kind of capital and energy generation usually reserved for nation-states. The reason for this massive energy demand comes down to how AI is changing. With the launch of Qwen 3.7 Max, we are seeing models transition from passive text generators into autonomous agents that take action on their own. When comparing Qwen 3.7 Max against GPT 5.5 Max on multi-step planning, tool use, and error recovery, the open model matches the frontier standard. These models execute continuous logic loops, verifying their own work, correcting mistakes, and running operations without human intervention. Because autonomous agents require exponentially more processing to run these continuous cycles, the demand for raw compute power creates an environment where only a few corporations can afford the entry price. But there is a counter-movement happening right now. High-level computing power is migrating out of server farms and onto consumer hardware. The hardware driving this shift is led by machines like the $3,999 AMD Ryzen AI Halo PC, which ships with 128 gigabytes of unified memory. Traditionally, splitting an AI model across graphics cards creates a data traffic jam at narrow PCIe connections, stalling local AI. Unified memory removes this barrier entirely, allowing instantaneous data access across the whole system, circulation previously impossible on a desktop. Software is squeezing even more speed out of this hardware. Tools like LM Studio now use multi-token prediction, a technique that guesses multiple words at once, effectively doubling local processing speeds for free. A single person with a $4,000 desktop can now wield the kind of computational autonomy that required an enterprise server farm just a year ago. That local hardware is being armed by a flood of massive, free-to-download AI models. Cohere recently released Command A+, a 218 billion parameter model that handles 48 different languages. Developers are finding ways to run these models on even cheaper setups. One recent project successfully ran the 284 billion parameter DeepSeek model on 4 obsolete graphics cards that cost roughly $2,000 total. Putting this level of power into the hands of anyone with a computer is creating immediate friction for established institutional systems. Adversarial actors are already using these accessible tools to manipulate Google's AI overviews, directly compromising the accuracy of the internet's primary search results. Institutional metrics are failing too. Harvard recently voted to strictly cap A grades at around 20% per course. When highly capable AI makes elite academic work trivial to produce, the traditional way we measure student success becomes meaningless. While big tech builds the central infrastructure, the independent users running open-source code on local machines are the ones introducing direct instability into how information is searched and education is measured. The talent that builds these systems is moving towards these two different futures. High-profile researchers like Andrej Karpathy are reportedly joining firms like Anthropic to utilize their massive centralized clusters. At the same time, software platforms are pivoting to survive the split. Cloud providers like Railway are rebuilding their architecture to be agent-native, anticipating a future where most traffic comes from AI agents rather than humans. On the local side, developer repositories are filling with agent orchestration tools like OpenHuman and M-Dash, which allow a single computer to manage dozens of AI assistants simultaneously. The technological landscape has split. The trajectory of this decade now rests on one choice: whether you rent your cognitive power from a central megacluster or own it outright on your own desk.